All right, guys, last video. So if you will please open up your Delta Math. You're going into the third part of your semester exam review, which is semester exam review part 3. Remember that all 3 of these are due by the end of the day, the Monday right before semester exams start by 5 o'clock. Okay, that's my first day back to work, so I'm going to give you guys that day if you have questions, you need tutoring, whatever. But we have this entire week to get this done, so that is the game plan. So let's take a look first at, I don't want to do a bunch of the transformations, but I'll just go ahead and do the first one. Let's do the one for, let's do transformation of logs. Okay, so this is the third question down from the beginning. Okay, so it says f of x equals log x, which best represents the transformation. Okay, so the first thing that I notice here, okay, is that I have a -2 on the inside. That tells me I know I'm going to go to the right 2. +3 tells me I know I'm going to go up 3. So automatically with the -2 and the +3, I know I'm going to the right 2 and 3 up. Or let's see, 2 to the right. Any other ones with that combo? Okay, well, all of these other ones pretty much have to be wrong, unfortunately. Okay, but if you look at this number in the front, which I do think is important, okay, 0.25 is the same as a fourth, okay, but I'm hoping that you realize that it's not in front like a normal stretch or compression would be. Do you see how that number is inside this set of parentheses? Remember that the numbers in parentheses always do the opposite of what you would think. So normally a fourth would be a compression, but because it's on the inside, that's why they're listing it here as a stretch. Okay, so just be aware, if that number was on the very outside, I would be calling that a compression all day. A fourth here like this, f of x minus 2 plus 3, okay, that would be considered a compression. Okay, but because it's on the inside in the parentheses, that's what makes that actually a stretch. Okay, and then if you don't remember the difference, on the outside, it's considered a vertical. But then on the inside, it's considered a horizontal. Okay, so if it's on the outside, it's a vertical, inside it's a horizontal, which kind of makes sense, right? Because the +3 on the outside is vertical, and then the -2 on the inside is horizontal. Okay, but that one ends up being super easy because basically all the other answer choices are wrong. So it doesn't even really come down to trickiness. Okay, let's jump ahead to the question, okay, that has basically no, oh, it's blank. I don't know what happened to that one. Just, I don't know what to put for that. What? Okay, when you get to this question that just says it's blank, just push enter on it empty and you'll get a free question correct. Okay. All right, let's go into the first inverse for me, please. So it says, for which function does an inverse not exist? So if you remember what an inverse is when you're supposed to switch the position of the x and the y. So what that means is that every equation has to have an x and a y for you to switch them out. Now remember that f of x is the same as y. So like, for example, this first equation is like y equals 3x plus 2. So it has one of each, cool. This is y equals square root x plus 6. It has an x, it has a y, I can switch them. Look at C. F of x is y equals 8. Uh-oh. Okay, there's no x for me to switch with that y. I can switch the y into an x, but then I'm not going to end up having a y in my equation anymore. Okay, versus on D, kind of the same thing as the other ones. If there's an X and a Y, I can switch them to find the inverse. But if I only have an X or I only have an f of X, which is basically just like a fancy Y, okay, then I know I'm not going to be able to find an inverse for that question. Okay. All right, let's go down to quadratic formula with imaginary solutions. Okay, I'm just going to go into the first one here. So quadratic formula with imaginary solutions. So it says, which of the following are solutions to the equation? Okay, I hate these questions, but here's the deal. Since it's the fourth power, basically we're going to have to do a little bit of work to be able to t-chart it. Remember, you can only t-chart once you get it down to quadratic, which is an x squared. So the first thing that I'm going to do here is I'm going to divide out an x equals -2. Now, if x equals -2 is a factor, that means that x plus 2 should be a part of this equation. And if it is, that means my remainder should come out to be 0 when I divide it. So I'm going to put a -2 in the box. 1x to the 4, -3x to the 3. Okay, a 0 for the x squared, that should be right here. But do you remember how if you ever skip a power, okay, that's like a 0x squared. Then I have a plus 8x, and then my 24, forgot to write this, but if it's on this side, that means really when I scooch it over, that's going to be a -24. Okay. So I'm starting with long division or synthetic division. So I'm putting a -2 in the box. I have a 1x cubed minus 3x, or 1x to the 4 minus 3x cubed plus 0x squared plus 8x minus 24. Carry the first number down. 1 times -2 is -2. -3 minus 2 is -5. -5 times -2 is 10. 0 and 10 makes 10. 10 times -2 is -20. 8 minus 20 is -12. -12 times -2 is positive 24. And then, oh, look at that. Okay, your 24s are going to cross out. That means you have a remainder of 0. That means that, yes, this is a factor. Now, my remaining answer, if my original was an x to the 4, is going to start as an x to the 3. So 1x to the 3 minus 5x squared plus 10x minus 12. And then remember, because my remainder came out to be 0, that means I know this really was a real factor. Okay, now take a look at the answers that are left. Okay, they all kind of look like they suck. So I'm going to pick the other one that looks kind of easy. I'm going to try this x equals 3. So I want to know, let me erase a little bit of this. And also keep in mind, I'm going to use this new shorter equation, right? Not the original one. So I want to know, could x minus 3 be a factor? Because remember, I'm always letting it be the opposite of what x equals. Well, then if I put a 3 in the box, I'm going to have a 1x3 minus 5x squared plus 10x minus 12. Carry the 1 straight down. 1 times 3 is 3. -5 plus 3 is -2. -2 times 3 is -6. 10 minus 6 is -4. Oh, wait, no, +4. And then +4 times 3 is 12. Ooh, look at that. We found another one. Okay, your remainder is 0. So that means my remaining equation, ugh, so irritating. Okay, so it's, if this is an x, it was originally an x cubed. This is now a 1x squared minus a 2x and then a +4. Okay, now, so I know -2 is an answer. I know that 3 is an answer. Your next move typically would be to try to t-chart this. Here's the bad news, okay? Richardson ISD loves to throw the hard stuff at you for no reason. Okay, so if you try to t-chart this, it's not going to work. Okay, the only way that you're going to be able to break that down the rest of the way is going to be to use quadratic formula. Okay, and you should notice, see all these little I's in here? Okay, we've covered those before. So I know -2 and 3 are both factors because I divided those out. I got down to something that's t-chartable, even though t-chart's not going to work and it's going to end up confusing everybody. So instead, I'm going to go this route. X equals -b plus or minus the square root b squared minus 4ac all over 2a. So that's my only option left. If t-chart doesn't work, that will always work. So my -b is going to be a -2 plus or minus square root. B squared is going to be -2 squared minus 4 times a is 1, oops, times 1 times, oh, this is looking, pretty janky here, okay? And then all of that divided by 2a, okay? So it's -2 plus or minus the square root, -2 squared minus 4 times 1 times 4 is what that says, kind of going down the side of the screen. So then remember, from here, let me actually switch to a piece of paper, okay, because that looks just totally hideous. So I have x equals -2. I'll erase all the writing in a sec. Plus -2 squared minus 4 times 1 times 4 all over 2a, which is 2 times 1. Okay, now remember, we already decided earlier, okay, that x equals -2 and x equals 3 are both solutions. Okay, so I'd have -2 is +2. Then I'm going to type that entire little chunk of numbers into my calculator. Just this, though, not the square root. So -2 squared minus 4 times 1 times 4. I get -12 over 2. And then, okay, so remember your list of perfect squares. Okay, you do have this on your formula chart. Okay, but one of your perfect squares is that the square root of 4 is 2. So if I wanted to split up this -12, I don't know if you remember this. We did cover this though, but it's -4 times 3. I could break that up into like a perfect square and then a leftover square. And then I would be like, okay, well then that's 2 plus or minus. The square root of 4 is 2. Then the square root of -4 would be 2i root 3 divided by 2. And then remember the last rule that we talked about. Anytime that all 3 of these numbers can divide by the same thing, you have to do it. So all of those can divide by 3. So that's going to be 1 plus or minus. I think I said that wrong. They can all divide by 2. So 2 divided by 2 is 1 plus or minus. 2i divided by 2 is going to be just an I root 3. And then 2 divided by 2 on the bottom is an over 1, which means that you don't have to write it. Okay, but make sure that you have that general equation written down. Okay, as long as you've kept your notes around, you should have it, but just in case. Okay, I'll put it there. Okay, so let's go back and take a look at the question we were just doing. We know that 1 plus or minus I root 3 is supposed to also be a solution. I don't see that as a choice. So that means that I'm only going to choose these middle two here. I know these two worked. Okay, this one is clearly missing the root 3 on the end, so that's why that one's wrong. So it's going to be 2 and 3 only, which is right here. So there still are 2 more answers, but they just don't have them correct as an answer choice. Okay. Okay, so this is the very last question on this part 3, which is not the process to explain on how to find an inverse and confirm 2 functions are inverses of each other. Okay, so the first one says that I can switch x and y. Okay, well that should sound familiar. We just talked about that. That is correct. Okay, another way would be the function should be reflections of each other across the line y equals x. Okay, this is also true. It's been a minute since we did this, but do y'all remember, I'm going to sketch it on here. When you have, like, let's say your parabola is here, and then we were like flipping it to the side and being like, oh, that's an inverse because it's a reflection across the diagonal. Okay, that's exactly what B is saying. Okay, y equals x would be this diagonal line right here. And so whatever your function is that's up here in blue, when I flip it, it should be here to the side. So you can switch x and y. You can look for the whole reflection thing. Okay, so A and B are both correct so far. Part C says, substitute each function into the other and see if you get x. That's also another way. Okay, and then this last one, this is the one that's wrong. Okay, it says, which is not the process. Okay, well, this says my functions should reflect each other across the y-axis. Okay, remember what we said. They should reflect across y equals x. The x is kind of like down here on the next line. Okay, but they should be a reflection across a diagonal, not across the y-axis. That's wrong. Okay, so D would be incorrect. Inverses, you switch the x and y, look for the reflection across the diagonal, okay, not across the y-axis. That is wrong. Okay. And then actually, let me go back and just talk about that other answer choice that we didn't really talk about. Okay, when you sub functions into each other to see if you get x, what that means is, like, think about a pair of inverses, like squared and square root. When I plug those into each other, they cancel out. I just get the x from the middle because the square and the square root cancel. Same thing with, like, if I had a cubic root of x and then I cubed it. Well, then the cube and the cube root cancel out. I just get an x left over. Why is that? Because they're inverses. So inverses always cancel out all of the extra stuff. That's what an inverse is. So like another example that we just covered last week, ln of e to the x, right? What happens? The ln and the e cancel out and you just have an x left over. So that's part of the definition of inverses, is that they cancel out with each other and the only thing that gets to stay is going to be the x. Okay. All right, last question here. Okay, so it says find the inverse of the function and then identify the domain of the inverse. Okay, so remember what we said, to find an inverse, okay, you're going to switch the x and the y. So that means that instead of this being y equals 4x over x minus 5, I'm going to switch it to be x equals 4y over y minus 5. Now, somehow I have to get that new y by itself. So what I'm going to start out with is I'm going to switch over to my paper actually here, since I have it out anyway. Okay, so we're switching the x and y, so it was y equals 4x over x minus 5. So I'm now going to swerve over here to my paper, and I'm going to write x equals 4y over y minus 5. Okay, so in order for me to split this up, I'm going to multiply. I'm going to cross multiply specifically. So 4y times 1 is going to give me 4y. Other side, I'm going to have x times y minus 5. Distribute that x into the parentheses. So I'm going to have 4y equals x times y is xy. X times 5 is minus 5x. Then I notice that I have y's on both sides, so I'm going to subtract these y's across to the left. Yeah, that is what I'm going to do. So I'm going to minus an xy off both sides. So I have 4y minus xy equals negative 5x. And then from there, what you should notice is that if both of these have a y, that means that I can take that y and GCF it out to the front. So for my next step, I'm going to pull the y out, and I'm going to have the 4 left over from the first term and the minus x left over from the second term. And then if that equals a negative 5x, I can divide the 4 minus x into the denominator. So I switched the x and the y. I kind of timed stuff out, cross multiplied. Okay, then I got all my y's on the same side. I GCF'd it out to the front so that I could divide by the 4 minus x. Okay, then from there, just to keep things easy, it's asking me about the domain that I'm just going to graph this guy. So I want a negative 5x divided by 4 minus x. And then I'm just going to look at the graph. Okay, I can see that right here I have something weird happening. Looks like probably it's an asymptote. Okay, it clearly goes like this, and then it goes like this. And remember, I can use the table to find where that error is. I don't see that error. Oh, there it is. Okay, see it? Okay, at 4, that's where my error is. So then that means that right here, this value happens at x equals 4. And remember that if I have an asymptote at 4, I cannot touch 4. So my domain should be from negative infinity to 4, union, and then 4 to infinity. Remember that you should have parentheses, not brackets, because you can't actually touch that value. You can get super close to it because it's an asymptote, but you never actually get there. Okay? All righty. Well, good luck, guys. Like I said, I will have tutoring available on Sunday. So if you need help, set up an appointment or get online 2 to 3:30. I'll be online at that point. I'll be happy to help, whether it's an old homework or a question on the review or whatever, okay? Also, don't forget, if you finish early and want to go back and work on an old homework assignment, that's totally fine. You just have to email me and let me know what you worked on so that I can go back and double check your grade to change it, okay? See you guys next week.